Hello, in this video let us talk about one of the techniques for integration, which is called U-substitution. So the U-substitution is a method that we use when we are trying to integrate a function that is a nested function. So what we have is we have one function and then inside of it is a different function. So here is an example below, and let's add a power to it. So we'll call it 2x plus 5 to the power 2 dx. Now, in this case, before we talk about the U-substitution, what methods do we have? Well, there is no power rule for the integral, not for the when the inside is more complex than the x. So the other choice we have is we could actually square this. We could multiply this out, and then we would have three terms, and we can integrate it, and we will get the answer without U-substitution. So let's do that first, just to practice how to do it and to have a different way. And then we will use the U-substitution and we will get the same result. Now, just keeping in mind that this technique of multiplying out works great for the power 2. But if this power happened to be more than 2, like 4 or 5 or 10, multiplying 10 of these terms out is just not practical. So the U-substitution then becomes the best choice by far. And so let us use first the way that we already know, and then we will do the U-substitution. So the way we already know is we could multiply out 2x plus 5. So if we multiply out 2x plus 5, let's just multiply it right here. We could use the formula for the perfect squares. That is also true. But in case we forgot, we can multiply out. 2x times 2x is 4x squared. 2x times 5 makes 10x, then 10x again, and then 5 and 5 makes 25. So here we have 4x to the 2 plus 20x plus 25. And we're still integrating this, and it's still dx. So now we have three terms, and we're integrating each one using the power rule, because the variable is just the x, not anything more complex like we had before. So now the power rule works. So let's use the power rule. So the power rule says that we add 1 to the power, and 2 becomes 3, and then we divide by that power. So the same goes for the next. X to the first becomes x to the second, divided by the power, and then the term without x gets an x. We can reduce because 2 goes into 20 10 times, so we can have 4/3 x to the third plus 10x to the 2 plus 25x. And we're evaluating from 0 to 1. So first we plug in the 1, so we set parentheses, and we plug in the first set of parentheses, we're plugging in the top value, and then minus, and in the second set of parentheses, we're plugging in the bottom value for all of the x values. So first time we have 4/3 times 1 cubed plus 10 times 1 squared plus 25 times 1. Now the second set of parentheses, everything gets times by 0, which turns to 0. So 1 to any power happens to be 1. So we have just 4/3 plus 10 plus 25. 10 and 25 is 35. 35 and 4/3 happens to be 36 and a third, which is also known as 36.33 forever. So this is our final answer. Now we have used the method that we know before, that we have studied before, which is just multiplying out and taking the integral of each term separately. Now we will use the U-substitution and see if we get the same answer. So for the U-substitution, we replace one part of our equation with a new variable, and we call it u or anything else that we like. So let's make u our inside function, 2x plus 5, and of course let's put back the square like we had in our first example. So now if we have a u, the idea is that we will replace all of our x's, these x's and these x's, with a new variable. And when we do that, the idea is that there will be no more x's, there will be just the u's. So all of the x's have to go away. And then we would be able to solve, hopefully we'll have a simpler question that has u's instead of x's, and then we would be able to solve it from there. So let's make the u substitution, and what we need is we need to decide which part is going to be the u. We also need to replace the dx with the du, which means we're taking a derivative of the u. So taking a derivative of both sides, the derivative of u is du, the derivative of 2x is 2 dx. Now we are solving for dx, so to solve for dx we need to get rid of this times by 2, so dividing both sides by 2, we have du over 2 is dx. So now we're making the substitution. We have the integral, the inside is now called u, so let's make it u. We still have squared, and then the dx is now called du over 2, so let's put that in. Now we have replaced all of our variables are now called u, there is no more x. The boundaries have changed, so let's not worry about this right now, but we can factor out 1/2 outside and we will just have the regular old power rule. So this is 1/2 integral of u to the 2 du. And that's a power rule. Now, how do you take an integral of u to the 2? Well, we add 1 to the power and we divide by it. There was also 1/2 outside that we just took out. So that makes 1/6 of u to the 3rd. Now, we remember that we didn't have the u to begin with. We have to go back to the variables that we started with, which is the 2x plus 5 is the u. So we replace the u with what it actually is, and we would have 1/6 times u, which is 2x plus 5 to the 3rd, and then we're evaluating from 0 to 1. So plugging in 1, we would have the 1/6 times 2 times 1 is 2 plus 5 is 7, so we have 7/3 minus, now we're plugging in 0, 0 times 2 is 0, 0 plus 5 is 5, so we have 5 cubed. So here is our numbers. Let's use the calculator to see if we actually get the same answer that we had with a different method. We had 36.3, so let's see if we get the same this time. So here's the calculator, and let's type in, well, let's just type it in the way we see it. 1/6 times 7 to the 3rd, and then minus 1/6 times 5 to the 3rd, and the answer is 36.333, which is the same as 36 and a third. Now, that confirms that we get the same answer using the u substitution, and the u substitution works even if this power happens to be 20, not just 2. And that's a much more easier way to do the u substitution. Now, there are some general rules of thumb where to use the u substitution and what not to make a u. But in reality, these come from practice. So they're not set in stone. And there will be times when you would make something a u and it will not work out. You will try something else, that will not work out. And that's a process. But in general, when you have a fraction, the denominator is usually made a u. If we have a square root, inside the square root is oftentimes made u. E to the power is oftentimes u, or the inside of natural log. If we have multiple parentheses, the one with the higher power is called the u. The inside is going to be the u. And so these are just some general principles that might help in making the u, the initial u. And then once we do that, then hopefully it works. If it doesn't, we try something else. The u substitution doesn't solve all the questions. It just is a very powerful rule that works. And it works as opposite of the chain rule for the derivatives. Now we have our answer 36.3. Let's also use the calculator to check the result, because we can do this with the technology as well. So here is our calculator once again. Let's type in our equation just the way it used to be, 2x plus 5 to the power 2. And here it is. So let's make a picture of it. This is the standard window from -10 to 10. And let's make a calculate, second calculate. The last choice is integral of a function. So we choose the integral. Lower bound is 0, okay. The upper bound is 1. That's a high number. And so here is our area, and it is equal to 36.33, just like we have thought. There is also a different feature on this calculator that also allows us to do the same, and we can get out of this. If we go to the math, the choice number 9 is function integrate. So here, if we have that feature, we can simply type in our integral just as we thought, just as we see it in our homework. So let's add extra set of parentheses, because we will need the square, 2x plus 5 to the power, come back, insert extra set of parentheses to the power 2, and then it's a dx. So here is the question. Let's see what the answer is, 36.33. So this is how to use the technology to check our answer numerically and how to check it visually with the area under the curve. And that's it for this video. If you have any questions on anything, please let me know. Thank you for your time. Take care.